Okay, class, good afternoon to everyone. Lecture topics for today, that is safety and environmental aspects in refining. One is a very important chapter, mainly related to the environmental issues, because so far we have learned what are the processes carried on in downstream processing. You already know that there are several physical separation process are occurring, including chemical conversion as well as physical separation. That is, that desalting process. Then main thing, the food distillation, that are the physical separation activities. Chemical separation such as catalytic cracking, reforming, fluidized catalytic cracking, hydrocracking, then alkylation, hydrotreating, then the thermal cracking and caulking. All these are chemical conversion. Chemically, they converted the feedstock to the products. In petroleum refinery, some other activities also carried out, such as blending. This is mainly for motor oil or grease, something for the manufacture of motor lubricating oil also. The blending activities is carried on. So actually, in petroleum refinery, that is a very complex in the processing um, plant. Lot of activities are carried on. Lot of pressurized equipments are involved. So we have to know what are the issues related to the safety and environmental issues, because actually the petroleum refinery, that is one of the major concern, one of the major source for polluting environment. It is polluting not only the pollutants or emissions, not only affected the air, including air emission. It can be affected water also. It can be affected solid, our soil also. So see, the normally, for example, if you compare the refinery with palm oil mill, for example, normally palm oil mill mainly issue with palm oil effluent, palm oil mill effluent, POME, whatever we are talking, mainly is related to the water, mainly some other issues also, but mainly POME, that is water related environmental issues related to the water, which is concern for POME. But petroleum refinery effluent, in short form, it is called PRE, petroleum refinery effluent. So it can be uh, emissions, can be a gas emission, can be liquid, as I told, that water, and solid also. For example, gas emissions. In petroleum refinery, as I informed, that lot of activities are carried on. So one of the gaseous emissions that are contributing, that is uh, the hydrogen sulfide. Hydrogen sulfide is a very toxic gas from many units. For example, this desalting unit, then from crude distillation unit also, then catalytic cracking and reforming, thermal cracking and caulking. Everywhere from here, the hydrogen sulfide can be emitted to the environment, including hydrogen sulfide, also some other gases such as carbon dioxide. You know, carbon dioxide it itself is a greenhouse gas, global warming due to that. So from petroleum refinery, sulfur dioxide can be emitted. Carbon, carbon dioxide, sorry, and sulfur dioxide as well as also sulfur uh, dioxide, then nitric oxide or nitrogen dioxide, NOx. Normally we are uh, telling NOx. So NOx or SOx. SOx stands for sulfur dioxide or NOx, that is nitrogen dioxide. These are the harmful gases. Due to nitrogen dioxide, ozone, if like nitrogen dioxide emitted to the environment, it may make ozone also, which is harmful for the environment. So, in other words, nitrogen dioxide or sulfur dioxide, if emitted, normally it is a form of general uh, uh, effluent or emissions from refinery. So, due to that, acid rain can be occur. As you know, that sulfur dioxide and in the air there may water vapor. So, water plus sulfur dioxide react and produce sulfuric acid. H2O plus SO2, H2SO4. Same thing, nitrogen dioxide also react with water vapor what presence in the air. So it can make converted nitric acid. So acid rain can be happen due to these gaseous emissions, which are coming from petroleum refinery. Carbon dioxide, as I told, carbon monoxide also, because you know due to combustion. As you know that uh, in refinery, there are a lot of combustion activities that carried on, especially for catalytic conversion process, because on those process we are using catalyst. So on the surface of the catalyst, the coke deposition is there. So for burning this coke, we are using air. So meaning that hydrocarbon react with air, produce combustion occur, produce carbon dioxide. So this is global warming is occurring due to that. I have read in one journal, if I'm not mistaken, the researcher based on that their research that every year due to global warming, due to carbon dioxide, the every 50 years, the temperature of the world increasing around 3 degrees centigrade. See, every 50 years, 50. So if such like that, so our uh, temperature will be increased. So for example, if present scenario, if you release carbon dioxide, for example, nowadays in Malaysia, on an average temperature, let's say 30 degrees centigrade. After 50 days, it will be automatically due to greenhouse effect, temperature will be 33 degrees centigrade. If temperature increasing, definitely it is global warming. The water level, seawater level will be higher. So a lot of countries such like Maldives, Madagascar, even Bangladesh also, or maybe some coastal area also, it will be under the sea. So we have to be very conscious about the environmental issues, especially from refinery, because uh, it releases a lot of toxic gases, as I informed that uh, hydrogen sulfide, SOx, NOx, carbon dioxide. Another problem due to impartial combustion also. With impartial combustion, instead of carbon dioxide, may produce carbon monoxide, which is very harmful. Carbon monoxide even worse than carbon dioxide. So it is due to impartial combustion. So this is related to the gases. On the other hand, in refinery, lot of washing activities carried on. You know, in desalter, that unit we are normally to remove the water salt from the crude oil. We wash with water. So with the washed water, it is heavily polluted. So uh, in the wash water, not only the harmful substances such as ammonia, uh, halides, chlorine, heavy metal such as lead, arsenic. Uh, so all these pollutions, water pollutions, can be due to uh, from various activities, whatever carried on in petroleum refinery. Other hand, as I told, that in petroleum refinery, not only gas emission or water pollution, in adding with this, the solid waste also generated. It has been proved that around 5 to 6 kg per ton solid waste produced for uh, around 5 kg solid waste produced if we for the refining of simple 1 ton of crude oil. See, for 1 ton of crude oil, if you do the refining activities for 1 ton of crude oil, around 5 kg solid waste produced. On the other hand, in the petroleum refinery, a lot of tanks are there. So in the tanks, on the bottom of the tanks, sludge also produced. So sludge with oil and grease and others, very thick sludge also produced in every tank. So whenever you clean, so these are the solid waste produced from the refinery. So in petroleum refinery, in all aspects, gas, water, solid, everything is polluting. So we have to be very conscious. That is why, in the beginning, I told that this chapter is important. Uh, so you have to know about what are the safety and environmental aspects in refinery very well. Actually, in this chapter, we carried out a lot of calculations. So please make sure that if you have a pen, calculator, and exercise book, because we will practice some calculations. So you will do the calculations uh, throughout this for next one or for next 2 hours in this class. So please take your calculator, exercise book, and pen with you. Everyone, please make sure that everything, calculator, pen, and exercise book with you, because we will do some calculations. Safety issues also we have to be concerned, because in petroleum refinery, lot of pressurized equipment are used and lots of flanges. Flanges means the connections. Lot of pipelines connections is there. So if connections is very poor connection, so normally if pressurized equipment and poor connection, so this uh, the hydrocarbon, especially low boiling temperature hydrocarbon may escape, and it is very common. That emission, this is actually calling fugitive emission. Fugitive. Fugitive means that the if the whatever the vapor or gases leak out due to poor connections in the flanges. So normally itself, as I told, that in refinery there are a lot of tanks and flares also. What is it stands for flare? I will explain later on. Flare might be some of you already know, but I will explain what the stands for flare. Flare actually, okay. Flare actually, the in every activities from, as I told, that desalter or crude distillation or catalytic cracking, reforming, alkylation, everywhere some gases are produced and some gases may escape also. So this gas capturing unit is there. So all the gases from the different activities in crude oil, they collect. That is calling manifold, or in other words, is calling blowout system. So all the gases, harmful gases collecting from different activities, collecting in one place, and then it is burned it out. There is a, you may see, I think you might recall in whenever we have visited in an Himanis plant, there is a long, uh, uh, the system, like a piping system, long tube of horizontally, and always on the top it is burning. So this is actually all the toxic gases collected from the different unit. So it is burning out. But also, although it is burning out, and it should be very high also, because if the height is lower, our environment, because environment will be heavily polluted, because this, there are combustion activities are carried on. So a lot of carbon dioxide, carbon monoxide, nitric NOx, SOx also emitted to the environment. So normally that flat system is very high. The this is always burning. So this is calling actually the flat system. So from the tank itself, if for example tank itself also emitted some low boiling point hydrocarbon to the environment, this is normal. Fugitive emission, what I want to explain you, fugitive emissions means that if any pressurized equipment or pressurized tank, there is some connections. If the connections, poor connection is there, some gases will be leaked, and it is very common. So we should not allow the poor connections wherever, if you are working or wherever in petroleum refinery, if you found that there is some leakage, especially hydrocarbon steam is still okay, although it is economically. If leakage, first thing we can say that it is already in, we are losing something. So leakage should not be allowed, especially for hydrocarbon leakage, because this hydrocarbon, whatever leakage as a vapor or gaseous form, this can be accumulated in the air, accumulated, and once upon a time it can be self-ignition. That is actually calling vapor cloud explosion, VCE. It is very common near about the any petroleum refinery if there are some leakage. So if leakage is there, it has to be immediately rectified. Otherwise, this hydrocarbon leakage, whenever leak to the air, so it can be accumulated and it can be exploded. That is calling vapor cloud explosion. This is very common. To avoid vapor cloud explosion, this is explosion. Might be fire also, because fire can be created from explosion. So we should not allow leakage in the pipeline or into the joint, right? Joint in the any elbows or any flanges. It should be tightly uh, uh, very tight and should not be allow the leakage of gases. Another explosion, that is the BLEV, you might heard about. BLEV actually stands for boiling liquid expanding vapor explosion. BLEV, BLEVE, BLEV. Again, BLEV stands for boiling liquid expanding vapor explosion. BLEV, how it is happening? BLEV, for example, any tank, there is a hydrocarbon, you store some liquid, hydrocarbon liquid. So as you know that every hydrocarbon has their own boiling point temperature. If, for example, you are doing some activities like such maintenance activities or uh, near the tank, or due to some reason due to some reason, maybe temperature increase, outside temperature increase. So if outside temperature increase, definitely inside of the tank also temperature will be increased. So if temperature increase above than boiling point temperature of that particular liquid, in that case, that liquid will expand, volume will be increased, and ultimately, if boiling point temperature increases uh, due to external source of fire or external source of heat, so it can be exploded. So that explosion is calling boiling liquid expanding vapor explosion flame. So VCE, as I told, that vapor cloud explosion or boiling liquid expanding uh, vapor explosion. These are the very common explosions happening in the petroleum industry. So you have to be very careful about that. So these are the uh, main thing what I want the concept of this of today's lecture. So all this our as a process engineer or petroleum engineer, we have to know only we should it is not enough only to know about the what are the emissions, gaseous or water or solid. You should know first what are the emissions come out from the refinery, but our responsibility to uh, provide the solution also, how to control or how to minimize the pollution. That is our responsibility. So how to minimize the pollution or how to control. So that is why you have to know how to you have to estimate the emissions first. So you have to calculate how many because uh, every units what are the emissions, there are some guidelines, there is some acceptable range or permissible limit. So uh, so you have to estimate what are the pollutions occurring from that particular unit. So if it exceed, so definitely you have to take the actions. So there is as I told, there is some guidelines, there is a SOP, that what are the part, we will go through those guidelines, but we have to calculate also how to estimate these emission rate. That is actually you have to calculate. Okay, so that is our responsibility. So okay, so as I told that okay, you might in the you might recall that whatever we have learned last couple of weeks and before MC also, that in refinery activity, in petroleum refinery, starting from desalting, there are a lot like alkylation, a lot of activities are carried on. For example, first activities carried on in petroleum refinery, that is desalting. Desalting means to salt the removal of salt, because in the crude oil there may contain some salt and impurities also. You might recall that the crude oil can be renamed as sour crude, sweet crude, medium crude. Based on API value, we can differentiate, and based on sulfur content, because in the crude oil itself, the main impurities, that is the sulfur. Because as I told that in every unit, the common pollutant or gaseous pollutant is hydrogen sulfide. This is actually due to sulfur. Hydrogen sulfide is very common. So that is why we have to capture this hydrogen sulfide. And actually, if we capture this hydrogen sulfide, we can convert it to sulfur also, which is very valuable product. Sulfur, because it can be used as a raw material for producing sulfuric acid. But if the sulfur present in the crude oil, and if you continue your refinery activities at presence of sulfur, that is very harmful. Because due to that, as we know, first that our catalyst will be deactivated. Conversion will not go higher, and yield also will be lower and lower. And emissions, that is the main concern. The emission, if sulfur or any other impurity is present, emissions, you already know that emissions can be SOx or NOx. So this is actually impurity. If impurities, if you not remove the impurities, so these harmful substances or hazardous air pollutants can be released to the environment. So first activities in the refinery, that is the desalter unit. So from the desalter unit, there is a device that is called desalter device. From that, hydrogen sulfide can be expelled because it is still crude. So there is a sulfur percentage is higher. Mercaptans is there also. So hydrogen sulfide is escaped from that desalter unit. Moreover, in the desalter, we are using de-emulsifier and anti-foaming agent. De-emulsifier, uh, this is actually polymer additives to accelerate the activities, desalting activities. And anti-foaming for reducing the foam, because when you do the desalting, the foam can be created. So these additives are using. So due to that, because in the washed water, in the desalter, when we wash the crude oil with the water, since using the additives, so washed in the washed water, whatever comes from the as effluent from the desalting unit, so there may contain heavy metals, these polymeric materials, and also caustic alkaline. It can be so water will be alkaline based. So could be content also chloride, ammonia, and other materials, which is very harmful. So see the desalting unit, first unit, it can remove hydrogen sulfide. On the other hand, it can be polluted water also. Next activity, crude distillation. In crude distillation, you know that there is a physical separations are occurring with the temperature. High temperature are there in different fraction we are getting. We are getting some intermediate products like naphtha, uh, atmospheric gas oil, kerosene, uh, some gaseous also from the top, also LPG, propane gas also we are getting. So everywhere there are some, the joint are there, some flanges. So due to high temperature, so the gas that gaskets means that when the piping or equipments are connecting, in between there is some materials to tighten the joint of the so that things can be done due to high temperature, and some low boiling point hydrocarbon can be escaped to the environment. Hydrogen sulfide also can be, because hydrogen in the desalter unit uh, cannot be 100% remove the sulfate. So hydrogen sulfide also can be uh, emitted from distillation unit. Wastewater is from generated from the crude oil distillation also may contain soluble hydrocarbons, and some we are using in distillation unit some anti-corrosion additives. So these additives also can be escaped in the wastewater. So see here also in crude desalter, crude, here also hydrogen sulfide. On the other hand, water also we are polluting such with the additives, and some soluble hydrocarbons may escape in the water. Next activity after the crude distillation, that is, you might recall, that is catalytic reformer and isomerization. In catalytic reformer, since that is using catalyst, and in the catalytic reformer, main thing, the benzene produced as a as a undesired reaction of catalytic reformer. And as you know, benzene, this is a carcinogen substances. So benzene, we cannot avoid to produce benzene also in the catalytic reforming because it is undesired product of producing. So uh, this benzene has to be um, avoid, or we have to be tricked how to capture this benzene. In addition with benzene, there are some other like a toluene, xylene, BTX. Although it's very low quantity, it has been found that around point, uh, 0.1 to 0.5 kg, meaning half kg of this BTX can be produced uh, uh, if we uh, do the refining of 1 ton of crude. 1 ton of crude, when we do the refining activities, we produce around half kg BTX, which is very harmful. But we cannot avoid that. This is a toxic and harmful substances. So we have to do the appropriate technology how to capture this. Then another thing, in I forgot to tell, give the one information in crude distillation or in the desalting unit, whatever the produced wastewater, in this wastewater can be contained, including soluble hydrocarbon. There may contain some oil and grease also. So around 100 to 300 milligram per liter of desalting oil contain around 100 to 300 milligram oil. See, in 1 liter, if you do the analysis from the wastewater generated from desalting unit, so 1 liter of desalted wastewater may contain around 100 to 300 milligram oil. And you know, oil and grease is very difficult to remove, because you know oil removed from the water. But see, in desalting from the desalted unit, around 100 to 300 milligram per liter of water contain oil. It's a high amount. So actually, there are some appropriate technology. We will go through that. So it is very high amount, and some, you know,